Hello everyone, welcome back to another BGCSE past paper review. Today we are reviewing a combined science paper, and this is a paper 1 from the year 2019. Again, before you start your examination, you should always remember to write your school number, your candidate number, which is your personal number, your surname, and also your initials. Again, it's also important for you to read through the instructions carefully before you start the examination. And if you have any queries at all, you need to clarify those with the examiner before you start the examination. For this examination paper, they provide you with a periodic table, which is very nice of them to do so. And so let's go into question number 1. For question number 1 is at which level of organization is the kidney? And the kidney is an organ. So right off the bat, you know that that is B. All right. And so here now, number 2 is which is the process by which living organisms get rid of metabolic waste. And so metabolic waste are removed from the living organisms or from living systems by what we call excretion. So that's a straightforward thing. Digestion is the breaking down of food. Nutrition is the process by which you obtain nutrients. And of course, respiration is the release of energy from food. Number 3. For question number 3, so what is the name given to the liquid used for dissolving a substance? And this is a very easy question because everybody will remember this from mixing of substances to form a solution. And so this is the solvent. The solute is what is being dissolved within the solvent. So an example of a solvent is water. All right. All right. Alcohol could also be a solvent, but it's only for certain substances such as dyes and so on. All right. All right. Number 4. It's a diagram shows 4 different cells. It's a which cell are found in the lining. This is very important. The lining of the wall of the small intestine. So which of these cells can be found in the lining of the wall of the small intestine? Let's first identify them. And so the cell A here, they are representing smooth muscle cells. So this is smooth muscle cells. All right. And cell B, they are what we call ciliated cells. So these are ciliated cells. And for cell C, we call those sperm cells. All right. And for cell D, those are our neurons, or what we call our nerve cells. All right. So they are neurons or nerve cells. All right. So which of them are found in the line of the small intestine? Are very important. And the line of the small intestine is covered by what we call smooth muscles. So therefore, A is correct. Ciliated cells are found like places in the trachea. All right. Also the nasal cavity as well. All right. So that's where we find ciliated cells. All right. And of course, we know where we find sperm cells. We know where we find our neurons. Right. All right. Let's go to question number 5. It's a diagram shows the level of a liquid in a measuring cylinder. What is the volume of the liquid? So let's look at it real quickly. What we can do is let me zoom in a little bit. So let me zoom in some more. I get a bigger zoom in this. Let me go even bigger than that. All right, let's see how big we could go. Oh, I guess I gone too big, but anyhow, we want to see that. Yep, absolutely. So what I want you to see now is the level right here. Here is 30 and this is 40. So halfway is 35. And so a little bit above 35. Okay, so that's mentioned right here. That's a little bit above 35. So we're looking for that value a little bit above 35. So can we figure it out? All right. Before I go into the answer, what I want you to remember, whenever you're measuring fluids or liquids within a container, such as a measuring cylinder, you always read from what they call the meniscus. The meniscus is the lower part of that curvature on top of the liquid. All right. So you're looking for the meniscus and read from the meniscus always. All right. So let's go back now and answer a question here. All right. So let's get back into. All right. Good. And so again, remember we say it's a little bit above 35, right? So therefore it is not 35, it's a little bit above 35. So this would be 36. All right. Just a little tad above 35. All right. So 36. For question number 36, which of the diagram presents a mixture of the molecules of an element and the molecules of the compound? So we're looking here for elements and also compounds, right? All right, so let's now look and investigate exactly what is happening in the diagram. So let's look at diagram A first. For diagram A, you're going to realize a number of things. Here we have single units of something, and so if a single thing by itself, we call those elements. Let's just use E. That's elements, okay? So element is right here. However, here now, for this, you have two different shades, which mean two different elements. So this is a compound. So that's almost the answer right there. We're looking for elements, I'm looking for compound. So a single point by itself, or one of these circles, represent an element, and a combination of different elements give you a compound. Let's look at B to make sure that we are correct. Now, two of the same elements give what they call a molecule. So that is a molecule right there. Two of the same thing, molecule. This is a compound. All right, so we're looking for elements and compound. I just want to go through all of them to show you. But we identify answer here as A. In C, we have here elements. Again, once they are single by themselves, they are elements. All right, and once they join together, so two of the same elements form what they call a molecule. All right, so you need to know what's the difference between a molecule and a compound, right? In option D, we have one element right here, and the white is also an element, which is a different element, but they're not joined, so they're not compound. All right. Again, remember that a compound must be two different elements chemically combined, and a molecule now can be two different elements or two same elements. All right. And so A is definitely our answer for elements and compound. All right, let's go to the next option, which is question number 7. It says, which group of animals is cold-blooded with moist, soft skin? Looking for cold-blooded with moist, soft skin. All right, so first here, arthropods, they have exoskeleton, just to make a note of that, right? And matter of fact, all these, they are really cold-blooded, right? Because the only warm-blooded organism we have is mammals and birds. So there's no mammal here, there's no bird. But amphibian will actually be the answer because amphibians, they are moist, all right, and the skins are soft. We didn't say smooth, so don't mix up smooth. If you look at a frog, for example, the skin is not smooth because you can see like bumps all over it, right? But it's soft. It's bumpy, but soft. All right, so don't mix up bumpy with soft, all right? Or smooth or rough. We're not saying it's smooth, we're saying soft, which means you can touch it and squeeze it easily. Arthropods, they have exoskeleton, which means they have a hard covering, right? Fish, they have scales, right? Reptiles do have scales as well. So answer here going to be amphibian, all right? All right, so that's our answer there for number 7. I jump into number 8, all right? And number 8 is which picture shows work being done on a box? And just to investigate these carefully, if you remember what work is when a force causes movement. And in any of these diagrams, which is actually causing movement on the box itself, for option A, the man is lifting the box upwards, so there's a force being applied, and the box is being pulled or pushed upwards. For diagram B, the person is standing with the box. Matter of fact, even if the person is walking, the force is not being applied onto the box, okay? And even the wheelbarrow, the force is not applied to the box itself in the wheelbarrow. It's applied to the wheelbarrow, all right? And the wheelbarrow is moving. Obviously, now the wheelbarrow contains the block. So therefore, if the wheelbarrow moves, then the box is moving. But the box is not moving directly because of the direct force on it. In D, the box is sitting on the person's legs. The box is not moving, and so therefore it's not work done on the box. So the only diagram that's showing that work is done on the box directly is actually option A. All right, so question number 9 is the diagram shows a simple food chain, right? It's which letter represents a secondary consumer, and a secondary consumer is a second consumer, right? So I guess let me just kind of quickly tell you that A is a producer, so this is a producer, and so here now, which is a caterpillar, this is a primary consumer. All right, so that's our primary consumer, and then now the lizard, it will be our secondary consumer. Okay, that's our secondary consumer. And then D now will be our tertiary consumer. All right, so let's list D as our tertiary consumer. All right. Now, that's a point to make right here, right? Is that in this food chain here, we have 4 trophic level. So trophic level is each level of the food chain, right? So the producer is the first trophic level, the caterpillar is the second, the lizard is the third, and the bird is the fourth. So there are four trophic levels in this food chain. Question number 10 is which diagram shows, oh, I did not answer this one up here. So it said the second trophic level here is, or the secondary trophic consumer, I should say, is actually C. All right, the name is there, secondary consumer. All right, there's also a carnivore as well, right? Just to point it out. But question number 10 is which diagram shows the structure of a vein. All right, and so a vein is thinner than an artery, and the lumen is wider. So I'm going to kind of point out something real quick. So notice in the artery, that's a lumen right there that I'm putting that line on. And in the vein, this is a lumen right here. That's a vein because it's of a wider lumen and a thinner muscular wall. All right, for diagram C, it will be a plant stem. And for diagram D, it is a capillary, one cell thick. You can see the cells within diagram B. All right, it's a very thin structure. So yes, our answer here will be B. B is our vein. Veins have thinner walls compared to arteries and also wider lumen. And lumen is the diameter of the tube section of the blood vessel. Question number 11 is, what is the best way to obtain pure water from salt solution? And if you want to collect the water, then distillation is the best process, because while the water is evaporating, it will condense back into liquid water. All right. For evaporation, you can use evaporation, but the only thing with evaporation, you're not going to get the water. You cannot collect the water. What you get back is the salt, because when you evaporate the water, the salt will remain in the container. So it's a good way to get the salt, but not the water, for D. So the best answer here is A, because you can collect both the water and the salt. All right. And notice the key word is obtain pure water and from salt. So the best way to do it is actually distillation. All right, so number 12, it said, what is the substance brass classified? It said, how is this substance brass classified? How? So it's classified what they call an alloy, because an alloy is a mixture of 2 or more different metals. So that's what an alloy is a mixture of 2 or more different metals. All right. I think there's a paper which they talk about some alloys, which I could also go through some examples. So I guess I think it's a paper 2. So when I go through that, I think there's a question on that for it. So I will talk about different types of alloys then. Question number 13, it says, which particle is always moving when there is an electric current in a conductor? And once electric current is moving, it's because of flow of electrons. So electrons will be your answer. And electrons are able to flow through the conductor or through the metal. For question number 14, it states that the diagram shows a woman holding a pot on a stove. A cooking pot is hot, but the handle of the pot is designed to stay cool. And so if she hold on to the handle and laughing like this, then it cannot be hot at all. Because if that was hot, then she'd be crying or flashing her hands. So she's cooking very happily. I guess that she's cooking probably some peas and rice, I guess. But she's happy though. Or some crab and rice maybe, or crab and dough. All right, but she's a happy woman. All right, so which material could be used for the handle of the cooking pot so that it is cool? And so we're looking for an insulator. And so an insulator here is the hood. All right, so aluminum, copper, and iron, they are metals. So of course heat will pass through them easily. So those could not be the answer. For question number 15, it said diagram shows a food web. All right, and so we have a food web here. We have rotten leaves, we have fungi, we have insects and mites, we have ground beetles, we have raccoons, we have black crows, we have the thrashers, and we have the earthworms. But let's see what they ask us to do. It said, what will happen to this food web if the earthworms, insects, and mice are removed? So if you take them out, let's take them out. So let's say take these out. So if you take out the insect, that means that arrow is no longer existing. If you take out the mites, that means this arrow is no longer existing. If you take out the earthworm, this arrow is no longer existing. So in other words, no, nothing is eating life. Not say nothing because the fungi is still there. Only fungi is eating the rotten leaves, right? So there's no other thing feeding on the rotten leaves. A matter of fact, does make a point right here is that all of these organisms, they will become extinct because they have no food, right? Because all of them directly or indirectly feed on the insect and the mites. A matter of fact, there will be no trashers as well because the trashers, they feed on the earthworms. So the only organism that actually left back in this food web here, well, not a food web anymore, but is a rotten leaves. Okay, so the simple food chain that will remain. So the complex part of a food web will be gone, leave only a single food chain. All right, so let's talk about what is happening here. Let's get option A. For option A, so the population of black crows will increase. Foolishness, because guess what? Black crows will become extinct. No food to eat. Part B, it said here now the population of fungi will increase. All right, what do you think about that? I believe so, that it will increase. Why? Because it is the only thing eating the rotten leaves, so therefore nothing is eating it. So there are two reasons here. Nothing is eating the fungi anymore. No insect eating the fungi anymore. Plus, it has enough food for itself. So you have a lot of food resources because it's the only thing eating on the rotten leaves. And guess what? It has no predators. So B seems good so far. Let's look at C. The population of raccoons will increase. Nah, that cannot work. Impossible. D, the population of thrashers will increase. No, that will not work. So our answer here has to be B, okay? All right. The population of fungi will increase. One, because of no predators, and two, because more food is available to it or to them. Number 16. The diagram shows the amount of energy at trophic levels 1 and 4. Only 10% of the energy is passed on to the next trophic level in this ecosystem. So guess what? If this is 10,000, then only 10% pass on. That means this will be 1,000. And if 10% pass on from this, this will be 100. And so if only 10% from 100 pass on, it will be 10, which is given already, right? And so what is the total amount of energy in trophic level 2 and trophic level 3? So we're looking here for the combination of 2 and 3. And so 2 and 3 will be here, all right? So these two together. And so that's a total of 1,100. So answer here has to be C, a total of 1,100, which is C. All right, let's go to our next question. Our next question here now is question number 17. It said, which of the following pairs have a similar relative atomic mass? When it says similar relative atomic mass, let's look at the molecules first, or the particles first, to decide which of them will be the same relative atomic mass. Now, electron and protons, absolutely not, because electrons, they do not have a mass. They have a mass of 0. All right, technically they do have a mass, but for this examination, we're going to say it's 0. Okay. All right. So it's taken to be 0 at the national level in terms of the basic sciences. All right. It is 0. All right. Now the proton has a mass of 1. Electron again is 0. Neutron also as neutrons, they have a mass of 1. All right. So these two are incorrect for A and B. Again, neutron and nucleus. Nucleus is a total of proton and neutron. So the proton and neutron give you the nucleus. So it cannot be the same thing as a neutron because it's going to be more than a neutron. The mass of the nucleus is more than a neutron because the mass of the nucleus is a proton plus the neutron. Okay, so it's both of them together. So they are different. The nucleus has a higher mass compared to the neutron. So the only answer there for real is has to be B, and it's B simply because in B, what do we have here? We have neutrons have masses of 1, and protons, they have a mass of 1 as well. So they have similar relative atomic masses. All right, for question number 18. And for question number 18, it said the electron configuration of an element is 28882. All right? It said which period would this element be in? And how do we determine what period that element will be in is based upon a number of shells. And so based upon this element here, it has 4 shells. So guess what? The first shell holds 2. So that's our first shell. That's number 1. Second shell holds 8. Next shell 8. And the next one go up to 8 as well. But in this case, it only has 2 to put on that shell. So this is the, I should have put third. So this is the third shell. This is the fourth shell. So the number of shell determine the number of period, or the period which is fall in. And so we know if we have 4 shells, it must be in period 4. But before I go to that, I want to ask you something. Based on this electrons that I'm circling, it's actually called a valence electron. And the valence electron determines what of the element. Think about it and then you answer it. I mean, I won't tell you now, but if you pause and think about it, then it'll be good if you get this. But the two valence electrons tells us that this is in group 2, okay? So it's in period 4, but group 2. The number of valence electrons, which means the electrons on the last shell, tells us which group the element is placed in. But the number of shells tell us the period. And so therefore, this is period 4. Right, but it will be group 2. If they should ask something like that, here is group 2. All right, so 19 now. We said which component pushes the current through this electrical circuit. And so what pushes it is what actually supplies it. And here we have A is a bulb or a load. So A is a bulb or a load. I could actually label that for you real quick. So A is what they call bulb or load. Okay, so it's a bulb or the load. All right, so it's a bulb or a load. B right here, which is symbolized by A, it is actually a meter. So this here is a meter. All right, and then C now, which will be a battery. And the battery is made up of cells. So this is just a battery with 2 cells. And this here is a switch. Okay, that is a switch. And so what pushes the electron through the circuit is actually the battery. So C will be our answer right there. What uses the current will be the bulb or the load. A meter reading the amount of current flowing through the circuit. And D, which is the switch, it controls the opening and closing of the circuit, which means it controls the flow of electrons or flow of current. Number 20. It's a diagram shows a portion of a nephron showing blood entering the capillary at X and blood leaving at Y. So let's quickly put something here again just to make sure that we understand what is going on. Blood is entering at X and leaving the capillary at Y. All right, so X going, the Y arrow going out there. All right, so it said which substance in the blood remains the same at X and Y? All right, no, this is a very good question here. What remains the same at X and Y? And remember now at the glomerulus, which is the network, I'm just going to shade this. All right, let me take this out. All right. Yeah, so the part that is shaded right now, it is called a glomerulus. And the glomerulus is where ultrafiltration takes place, which means substances will leave the capillaries and enter the Bowman's capsule. All right, so things that could pass through the Bowman capsule include glucose. It include urea and also water. What cannot pass through is proteins. The blood proteins remain inside of the blood and will just transport throughout the blood continuously. All right, so the one that is cannot able to pass through here is the protein. Now, there's a point to note as well that glucose is taken out, but glucose also returns. And the reason for that, because glucose enter because it could pass through easily, but it is reabsorbed in the capillaries. Now, the thing is that glucose is different even at X and Y because some of the glucose will be used within the cells, within the nephron itself, to carry out its function, also respiration, because energy is needed in the nephron as well. All right, number 21. It's a diagram shows 2 components of blood, P and Q. It's a which row in the table gives the functions of components P and Q. And P is a platelet and Q is a red blood cell. And so if P is a platelet, then P will help the clot blood. So there's only A and C could be the possible answer. And Q is red blood cells, and what red blood cells do is they carry oxygen, and so therefore, or absorb oxygen, or transport oxygen. And so A will become our only possible answer right there. All right. Next question. Question number 22. It's a diagram shows gaseous exchange in an alveolus. Where is the diffusion of the most carbon dioxide likely to occur? And if you think about it carefully, in terms of occurring, let me just kind of mark off some things right here as quickly. Blood coming in, so therefore diffusion will not take place here that easily. Let me say, let me put an X there, not taking place there easily. But at this point, you have carbon dioxide coming out of the blood. At this point, you have most of the oxygen going back into the blood. So our best answer there has to be B. Yeah. I said where most carbon dioxide is where is the diffusion of most carbon dioxide likely to occur, which means leaving from the blood into the alveoli. With this is alveolus because it's singular. So it leaves from the blood into the alveolus, and then it will be excreted by exhalation. All right, let's go to the next question now. And question number 23 is, which group of the periodic table will this atom be found? You know, we talked about something earlier, and we talk about how we can identify the group that an element is placed in, and it's based up on the number of valence electrons. And so what we're going to do is count the number of valence electrons here, and then we determine which group is in. So with 1, 2, and with valence electrons, the last set of electrons are the outer electrons are 3, 4, and 5. So this will be placed in group 5 because it has 5 valence electrons. All right, and motherfucker is also non-metal because non-metals have 5, 6, or 7 valence electrons. Number 24 is, which of these waves is a longitudinal wave? All right, and so you need to know the difference between longitudinal and transverse waves, and also some examples of transverse waves versus longitudinal waves, and you also need to know some examples as well. So here now, the longitudinal wave is a sound wave. Sound wave is longitudinal. The others are transverse waves. And so just to make a note that microwaves and radio waves, they belong to what they call the electromagnetic waves, all right? Just to mention that, but they are also transverse wave, just the same as water waves. And what happened there is that the vibration moves at right angle from the direction of the wave. In longitudinal wave, the vibration or the disturbance will move parallel in terms of the direction of the wave. All right, so question number 25, and this is halfway through the paper. And it's a diagram shows a wave. All right, and so we have some label part here. So let me just kind of label some stuff right here. A is amplitude because that's the highest point from the undisturbed position or from the direction of the wave. So the undisturbed position to the highest point of the wave is what they call an amplitude. Okay, that's amplitude. Now B is really nothing that we describe on a wave. C is nothing that we describe on a wave as well. But D is what they call a wavelength. And the wavelength is the distance between two consecutive crests or two equal points on a wave. All right? And then the line here is called the undisturbed position or the direction of a wave. Depends on if going left to the right or right to the left, depending. Now, it's which letter represents the amplitude. Okay, we actually answered that. So A is our amplitude. All right. A is our amplitude. Okay, yeah. So A is the amplitude. All right. We also need to know crest and trough, right? So crest, let me just quickly put that. The crest is that peak up here. So this is the crest. And trough is the lowest point, which is the opposite of a crest, but is on the lower end. So that's a trough right there. All right. Question number 26 is a dilute hydrochloric acid is added to copper carbonate and a gas is produced. How is this gas identified? Now, the first thing you need to know is what gas is produced when you react an acid with a carbonate. Because hydrochloric acid, well, it's an acid as it obviously state, and a carbonate, so you need to know those reactions. You also need to know reaction with acid and hydroxides or oxides, which are called bases or alkali. All right, we also need to know the reaction between acids and metals as well. All right, so here, if we react copper carbonate with hydrochloric acid, what we're going to get is we're going to get copper chloride, right? We're going to get copper chloride, and we're also going to get carbon dioxide, and we're going to get water. So the gas that produces carbon dioxide from carbonates when you react with acid. And how do you test carbon dioxide? Is put it in lime water, which is colorless, and lime water will turn milky. So we know that option C is our answer because carbon dioxide is produced from carbonates, and carbon dioxide turns lime water cloudy, white, or milky. Or you may see white precipitate if you want to describe it as that. Now, number 27. And number 27, it states that the graph shows changes in lactic acid concentration in the blood as a result of vigorous exercise. And so on the y-axis, you see lactic acid concentration. You can see that is low and then it increases and it drops again over a period of time. It's a which statement describes the metabolic process that causes the increase in lactic acid. So what chemical reaction? So when you see the word metabolic, it actually means chemical reactions within the body. So looking at option A, is that aerobic respiration results in a complete breakdown of glucose in the skeletal muscles, which is not true because aerobic respiration um, does not produce lactic acid. It produces actually carbon dioxide, water, and energy. And so B is a aerobic respiration result in incomplete breakdown of glucose. Not true for aerobic respiration at all. But C, anaerobic respiration results in incomplete breakdown of glucose in the skeletal muscle. Yes, this is it. This is it. All right. For part D, anaerobic respiration results in complete breakdown. Don't read any further because anaerobic respiration resulted in complete breakdown of glucose. So yes, C is our answer right there. All right. 28. It said the table shows the result of an investigation into the volume of air breathed in at rest and after running. So here we have at rest amount, and here we have after running the amount. And it said what volume of air breathed in will be carbon dioxide after running. And so let's do a quick calculation here. First point to note is what is the percentage of carbon dioxide taken into the body. And so you may see two numbers. Generally, you will see 0.03. So inhale here contains 0.03% of carbon dioxide. I must write CO2, but you know that the 2 must be a subscript of this, right? So we have 0.03% of carbon dioxide present in air once you're breathing in. Okay, this is inhaled air. All right, so we notice it said that the volume here, we're looking for the volume breathe in, and this is the volume breathe in one breath in terms of centimeters cubed. So watch this now carefully. If after running there's 1,000 centimeters cube of air, what percentage of that is carbon dioxide? So all I need to do is to find 0.03% of 1,000. So we're going to say 1,000 multiplied by 0.03%. And that is what's the result there. All right, so what you can do is to just divide 0.03 by 100. And if you divide 0.03 by 100, let's put it right here. So just divide this by 100, not 1,000. What we can get here, we're going to cross off these two zeros real quick. All right, so we cross off these two zeros. All right, we cross off two zeros here as well. So what do you notice here? We're going to multiply the 0.03 by 10. And what you do there, get 0. So that's a quick mathematical thing. All right, so what you get there is 0.3 centimeters cube. All right, so that's the answer there, 0.03. That B is our option. Okay, B is our option. All right, next question. And this is question number 29 now. So the diagram shows part of an ammeter, I should say, measuring current in a circuit. So you're measuring current in a circuit by an ammeter. And it said, now what is the current in the circuit? And so again, this also see if you can read lines pretty much. So this is kind of giving you a little chance to prove if you can read instrument. And so the only thing you need to know right here is that from the 0 mark to the 1 mark, there are 10 lines, right? And so if there are 10 lines, what you can do is to divide 1 by 10, and you get 0.1. So you get a 0.1. Each of these will be 0.1, okay? All right, so 0.1. All right, so if each of them is 0.1, then moving to the second line must be 0.2, right? So yeah, it is 0.2, which is B is our answer. As I said again, all I need to do is divide the number here, which is 1. 1 divided by 10 strokes is, so 1 divided by 10 stroke is 0.1. So each of these line values at 0.1. All right, let's go to the next question. 30. It said, which organ is responsible for the chemical breakdown of alcohol? And we know that straight off the bat is the liver. The liver detoxifies the body, okay? The kidneys only get rid of the waste, the metabolic waste, such as urea, okay? The brain do not chemically break down anything. What the brain does may send hormones and other signals for these things to happen, but the brain itself is not causing a chemical reaction. Stomach, nah, not to break down alcohol, right? But of course, digestion of proteins takes place within the stomach. All right, so question number 31 now. It's a question 31, which row in the table matches the structure of the alimentary canal with its function. And so the anus for assimilation, absolutely not. The anus is for egestion, getting rid of undigested food. Assimilation is when the nutrients become part of a cell. For example, amino acids come together to form proteins. That's what assimilation is. Large intestine for digestion, absolutely not. Digestion does not take place in the large intestine. You need to know that. What takes place in the large intestine is reabsorption of water, okay, or the production of vitamins. All right. So in the mouth now, it said the mouth is for ingestion. Absolutely, you use the mouth to ingest. You're taking food. So ingestion is the process by which you take food in. Stomach is for egestion. No, egestion is for the anus, as we talk about. The stomach is for digestion because you have chemical digestion taking place there, and also physical digestion because of churning of food. So the mouth and ingestion is the correct answer. Number 32. It's a bee sting is acidic. Yeah. So if a bee sting is acidic, it said which OSOL substance will neutralize a bee sting? All right, and I want to tell you right now, if a bee sting is acidic, I'm going to neutralize it. None of these things are showing are actually correct based on the pH values. Because what neutralizes an acid will be a base, right? But I'm going to show you there's a little mistake here though. All right, truthfully, the substance, the household substance that break down bee sting is actually baking soda, right? Baking soda is very good if you dilute it with some water or mix it in, dissolve it in some water and paste it over the area. Yes, it does a great job in neutralizing the methanic acid within the bee sting, because bee sting and wasp stings, they contain methanic acid. Even if you get ants bites, depends on the type of ants, matter of fact, they release methanic acid into your skin and it starts to give you a burning sensation, and some of you may have even serious reaction to it. And so the correction to make here is this, that the pH of baking soda is not 4 at all. So this may be a mistake. So the pH of baking soda is about 8.3 to about 8.5. So anywhere between 8.3 to about 8.5, thereabout. Unlikely to reach 8.5, but yeah, but 8.4 possible. All right, but let's say between these two numbers, you actually have the pH of baking soda. And so baking soda is actually a base, right, or an alkaline. And so the answer here is actually A. All right, answer there is A. Acid cannot neutralize acid. Just to make a note of that. So notice that is the bee sting is acidic. Acids cannot neutralize acids. All right, so part 33, question number 33. It said, which drug is an hallucinogen? An hallucinogen make you see things, hear things, and sometimes talk foolishness too, yeah? So anyway, don't do drugs, yeah? Please don't do drugs. Don't do drugs. All right. Alcohol is what they call sedatives or sedatives, or we may also call it, let's say, it can also fall under depressant as well. Okay, so it can be a sedative or depressant. Cocaine is a stimulant. It make you hype in energy, increase in energy, or boosts energy in a sense. All right, so it is a stimulant. So it stimulates you in a certain way. All right, so make you kind of feel hypo. Marijuana is what they call, marijuana is answer is a hallucinogen, and it also make you see things. It energizes your body somehow, make you feel high. Yeah, so that high feeling. So and that high may not be good for you because it can become addictive, or not even be addictive, but it can also affect you otherwise. All right, so nicotine is what they call a stimulant. So nicotine is also a stimulant as well. All right, let me just change this word to stimulant. All right, yeah, so nicotine is also a stimulant, just to mention that. All right, and again, it increases alertness. Stimulant increase alertness and make you feel a little bit energized and all that. All right, so yeah. Caffeine is also a stimulant. So caffeine will fall under stimulant as well, right? Caffeine will fall in that category as well. And what sedatives do, sedatives and depressants, they kind of slow down your central nervous system. And so that's why persons are drunk or intoxicated by alcohol. You notice they behave slower in terms of their movements, and they do not know what is going on. They have not much cognitive controls at all. They do not know what is going on. Their brain is not able to think straight. All right, so yes, our answer here is actually C. All right, marijuana. hallucinogen, cause it to hallucinate, see things, hear things, do foolishness sometimes. Do not do drugs. Stay in school, learn. 34. The diagram shows water waves in a ripple tank, and we have a glass block here at this end to the right. It's a which pair of qualities change as the wave move from deep water to shallow water. Just to make a note right here that waves travel faster in deeper water, and they also have longer wavelengths. So there are two things you need to know, that wave, they are faster in deeper water, and they are slower in shallow water, and they have shorter wavelengths in shallow water, and also longer wavelengths in deeper water. So our answer here is amplitude and speed. No, actually wavelength and speed. Those are the two things that change. Again, let me just put longer wavelength in one part, and the next part going to be shorter. All right, so this have longer wavelength, just to make a note. All right, of course, in the shallow, we'll have shorter. All right, just to kind of outline that. So just in case you need that information, you will have it right there. Now, 35, it said, what is the chemical formula for magnesium hydroxide? All right, so for magnesium hydroxide, let me tell you exactly how to get this, right? Just quickly. Magnesium is from group, let's put it here. Magnesium is from group 2, right? Mg. I'm going to show you this. If it's from group 2, we're going to have a positive 2 charge as an ion, right? Hydroxide, you need to know this, that is OH. OH has a negative 1 charge. And so I'm going to bracket this for a reason here. The whole thing is negative 1. The entire thing, not the H, but the entire thing is negative 1 charge, right? I'm doing a bracket there just to make my life easier, what I'm going to show you right now. To form compounds and you have ions, what you need to do is just carry these numbers down. We call them crisscross them, right? So that's going to be 2 there, and this minus by itself is a 1. So just to kind of point that out. So what do we have here as a formula is Mg, which is 1. So it's Mg1. All right, so Mg1 and OH2. So this will be magnesium hydroxide here, which is, So question number 35 is actually C is the correct answer. All right, so C is the correct answer. 36. For 36, it said the diagram shows a 150 grams of wooden block and its dimensions. All right. Here now say, what is the density of the block? But how do you find density? How do we find density? That's the first thing. Now, density is mass over volume, right? So let's get a quick formula so you know exactly how we're going to do this thing. So density equal to mass over volume. So density is equal to mass divided by volume. Okay, so just to know that, that's a formula for density. So the density now we need to find the mass. The mass here is 150 grams, all right? So now we find the volume of this block. And the volume of this block going to be 2 times 3, which is 6, okay? Times 5, which is 30. So it'll be 2 times 3 times 5, which is 30, okay? And so it will be 150 divided by 30. So let's quickly put that down here. So the volume here, let me just put that volume. Volume equals to 30. Let me just say it 2. Let me work it out for you real quick. 2 times 3 times 5 equals to 30. And it's going to be 30 centimeters cube because it's a cubic dimension, right? And so now we have our mass. So we're going to say the density now equal to mass, which is 150 divided by 30, which equals to 5 grams per centimeters cube. So that is now our answer right here. 5 grams per centimeters cube is our answer. All right, there's a typo here because the cube is supposed to be a superscript of the meters, right? So that's a little small error there. All right, nothing to worry about, nothing too serious. The answer is 5. 38. It said, why is water from the water table in the Bahamas considered to be hard when tested? So he said that group contains pollutants. It will contain pollutants for real, I will agree for sure. But that's not the reason why it's hard though. It contains sodium chloride. Now, sodium chloride is a salt, and it does give some hardness to it, but not that strong because it said because the water table is high and all that. We're talking about underground water. It's not necessarily because of sodium chloride, but they contain ions of group 2 elements. And group 2 elements are the main elements that are responsible for water to become hard. And they call it alkaline earth metals. So let me just write that down for you. So these are called the alkaline earth metals. So alkaline earth metals. All right. And so they dissolve in water quite easily. An example of alkaline earth metal would be like calcium. So let's say example calcium. Not even only calcium, but even magnesium. Anything from group 2. So you can look at the periodic table, look at group 2. They are all alkaline earth metals. All right. 39. Question number 39. And the question number 39 is a diagram shows an unloaded spring hanging from a support and the same spring loaded with a 6 kilogram mass. All right. All right. So this is Hooke's law. All right. They said, what will be the length of the spring when it is loaded with a 2 kg mass? All right. So let's do some quick calculations to kind of break this down for you to make you understand this thing. First and foremost, the spring with nothing is 10 centimeters, right? The spring with the 40 centimeters, the spring with the 6 kilograms is 40 centimeters. So the extension of this spring, let's call this extension. So the true extension of this spring when 6 grams is added to it is actually equals to the 40 minus the 10, right? So we're going to say 40 minus 10, and that's going to equal to 30 centimeters. So the extension caused by the 6 kilograms is actually 30 centimeters. You see that, right? Because the unstretched spring, at this stage go to 40, that means the real stretching is only 30 centimeters. All right, so we call it that. Now, next thing we need to know is a formula right here that the force is equal to KE, which is the constant times the extension. Okay? So force is equal to KE, constant times extension. Now, what this constant is really the amount of extension caused by 1 Newton force, right? So much extension per force. All right, but listen, let's now go through this now and apply a little concept here to find what is our constant value. We need to know what the constant is because the constant is what will help us to determine the other length or the mass. So follow me here carefully. Find the constant here. The constant is equal to force divided by the extension, right? So the constant is going to be equal to force divided by E. And the force here that we have, there are two things you could do. Let me just point this out. This is in kg, which is not a force. It's just a mass. But the truth is, you can still work it with the kg. You get the same answer. It doesn't matter. You're going to get the same answer. I promise you that. You will get the same answer. But the proper way to do this, though, is actually to convert the kilograms into newtons, I should say, which is a weight. So this is technically 60 newtons, right? So 6 kg is the same thing as 60 newtons. You multiply by 10, which is gravity, right? So the 2 kg here is going to be 20 newtons. I just want to point those out. Honestly, you can work with the 6 kg does the same and the 2 kg does the same. The answer will be the same. I tell you that. I promise you that. All right, but anyhow, let's jump into it, yeah? All right, so now I have my constant. No, I don't have my constant. I define my constant. My constant here is going to be now, as I said, the force divided by the extension. And so the force here is now, so the constant here is going to equal to the force, which is 60 newtons, divided by the extension. And the extension there is 30 centimeters. The 30 that we have found right here, right? So for the 60 newton, the extension is 30. So that means the constant of a spring is 60 divided by 30, which equals to 2 Newton per centimeter. So it's 2 Newton per centimeters as our constant. Now follow me now carefully. What it asks us here now, what will be the length of the spring, the length of a spring when it is loaded with a 2 kg. So all we need to do now is to find the extension, right? We need to find the extension. So the extension here, based on the formula, the extension will equal to the force divided by the constant, right? So the force divided by the constant. That's what the extension is. So the force here is 20, and the constant here is 2. So divided by 2, what we get here is 10 centimeters. But that's not the answer. That's not the answer. The extension is 10 centimeters. But the original length of the spring is 10 centimeters as well. So the length of a spring plus the extension give you the length of the entire spring when at that load on. All right, so we're going to plus the next 10 centimeters onto this. And so our total answer there, the total length is 20 centimeters. So A is our option right there. All right. Now question number 40, and we have 10 more questions to go. It said the word equation is incomplete. All right, the sodium oxide plus sulfuric acid, and this again is an acid plus an oxide, which I tell that we need to know the reactions of acid and base, the acids of and metals, the acid and carbonates. We need to know those. Also acid with metallic oxides. And so sodium is a metallic oxide. It's a which pair of products are complete the equation. And so if sulfuric acid should react with sodium oxide, what you will get is a salt and water. The salt that you're going to get here because of sulfuric, think about the name, sulfuric is sulfate, and then sodium. So the sodium will react with the sulfate to give you sodium sulfate, and the oxygen will react with the hydrogen from the acid to form water. All right, and so you get the sodium sulfate and water. So C is our option. All right, sulfate and water. Question number 41 is which diagram correctly shows the magnetic field for two magnets? Now, once you have magnets, there's something you need to know. It's a must-know thing. This is a must-know thing. That from a north and a south, let's talk about south and north real quickly. Once you have a north, what going to happen? Let's put N. Let's call this N, north, and let's call it south. The magnetic field lines always leave from north and go into south. So always leaving from north. I'm just doing like that. Actually, it should be on the outer side, right? But I'm just going to do that so you can understand what I'm saying. So it comes from north and then it goes into south. So south always receiving. I could draw it at the bottom. It doesn't matter. But the fact is, the arrows must go into south and must leave from north. Always. Once talk about magnets. Always from north and going into the south. All right. So if you look at option A, the arrows is leaving from north into south, which is beautiful. Let's look at B though. The arrows leaving from south into north. Absolutely wrong. Let's look at option C. Arrows going into north, which is absolutely not acceptable. And going to north, absolutely not acceptable. Yes, they will repel, for sure, because this is showing the repulsion. But the arrows are in the wrong direction. Let's get south and south going out. Now, remember that south will carry the field lines in. And so the only answer right here is our A answer, 41A. For 42, so the diagram represents the endocrine system. Which gland produces hormone that controls the concentration of sugar in the blood? And what controls sugar in the blood is insulin. And insulin is produced by the pancreas. So that's our pancreas right there. And so definitely that is our answer. A, let me just talk about what A is. A is the pituitary gland. And the pituitary gland is what they call the master gland. And the master gland is what control all the other types, all the other glands. All right, so that's the master gland. And the master gland controls all the other glands. And here we have what we call the thyroid gland. And the thyroid gland, what is produced what they call thyroxine. And it controls the metabolic reactions in our body, or controls metabolism. All right, so thyroid gland produces thyroxine that controls metabolism. And of course, C is the pancreas, and the pancreas produces insulin that controls sugar level. This dark structure on top of the kidneys, these are called the adrenal glands. So these are called the adrenal glands. One of them adrenal gland. The purpose for the adrenal gland is to produce adrenaline. And adrenaline is responsible for what they call the fight and flight. So it's the fight and flight response, which means when you're frightened, scared, angry, it gives that extra push of energy, a boost of energy, cause it to react or respond a certain way. Your pupil dilate and so on. All right, and D, it is ovary. So this is a female here. So those are the ovaries, not ovary, but ovaries. And ovaries produce estrogen and progesterone as we know it. All right, question number 43, and we're almost there. So how are the processes of burning and rusting similar? And burning and rusting, what you should know about burning and rusting is that they actually use oxygen, okay? And oxygen is used to produce an oxide. And so let me just talk about the oxide that are produced. So option D is actually your answer, but I want to talk about the oxides that are produced. Both use oxygen and produce oxide. And so if it's rust, let's talk about that. I'm going to talk about rusting there. I'm going to talk about burning right here. So I'm just quickly put rusting. So for rusting, once you're going to have rust, rust forms iron 3 oxide. So rust is iron 3. All right, so iron 3 oxide. All right, so the formula for it is actually Fe2O3. I'm going to write that down for you. All right, so you actually see that. And I'm going to write down the formula shortly. And burning now produce another oxide there, and that oxide is called carbon dioxide. So burning will produce carbon dioxide. All right, and also again, it is an oxide. All right. All right. And so based on formula right here now, iron 3 oxide is Fe2O3. Okay, so Fe2O3. And carbon dioxide is CO2. Okay, so this is CO2. All right, and so there we have it. So 44 is which diagram shows the path of light ray as it passes through a glass block. And so what takes place through a glass block is called refraction, which means the bending of the light. All right, and so A, as I look at A, I see that that is actually correct. Well, I'm gonna show you something, because the truth is that when the light passes through, and if you match up them like that, they end up going back in the same direction or same path. But the fact that within the block, it actually bends. So in other words, when light passes from one optical object of a certain density to a different optical density, then the light will bend. So the bending of light rays is called refraction. So diagram B, going in a straight line, you know that this is definitely not correct. Turning like this and going to the opposite direction is not correct, because again, I said if you match the line straight through, the two arrows will eventually meet, or the two lines will meet again. All right, they take bending within the block itself. This one definitely is out of range. It just don't make no sense. All right, so answer here is A. 45. For 45, then said a decline in levels of which hormone is directly responsible for menstruation. So when what decline, you get menstruation, and this is progesterone. All right, you need to know what the function of estrogen as well, because estrogen will be needed when you start producing follicles to repair the walls. But as soon as progesterone falls, then menstruation starts to take place. All right? All right, so let's jump into 46. So now question 46 is an increase in the concentration. An increase in concentration increases the rate of reaction because of what? So if you increase concentration, remember concentration is the amount of the substance within a particular volume. So if you have more substance by increasing the concentration, what you have is more particles. And if you have more particles, you have more collision of these particles. And if you have more collision of these particles, you have a greater reaction. All right? So here, no, so the particles are bigger. No, the particles are the same size. The particles are smaller. No, so A and B, oh, the particles get closer. Yes, because you have more particles within that same volume, then they are closer. They bombard each other more. They collide with each other more, and hence they react much faster and quicker. All right, quicker and faster is the same as redundancy, but yeah, they react faster. All right, now for question number 47, it says two cars start from the same point at 5 a.m. traveling in opposite directions at 40 and 50 kilometers per hour respectively, and it's shown in the diagram there. It says what will they be at 450 kilometers apart? All right, so what time? What time will they be 450 kilometers apart? And just by quick calculation here, what you need to know first is the total speed. Okay, so we need to have a total speed. So the total speed here equals to the 40 plus the 50. Okay, 40 plus 50. And so that equals to 90 kilometers per hour. All right. Now, the next thing here now, we want to find time. So we need to find time. And so to find time, what you need to look at now is remember the formula for velocity is equal to distance over time, just to mention that. And so therefore, time must equal to distance over the velocity. So time now is equal to the distance over velocity. So distance here is 450. So going to be 450 divided by our speed, which is 90. And so that equals to 5. Okay. So here we have 5 hours. So 5 hours is the time taken to reach 450 kilometers apart. And so if you think about it, if you leave 5 a.m. and 5 hours after 5 a.m. must be 10 a.m. So 10 a.m. is our answer. But you want me to show you something cool? I'm going to show you something real cool, right? If they take 5 hours to move from where they were to reach this distance, right? This distance is shared between them. If one car is driving faster, that means this out of this 450 kilometers, this car, which is the 50, moving at 50 kilometers, much cover more distance than the one at 40, right? So the one at 40 kilometers per hour will cover less distance. So out of this 450, how much distance was covered by the car with the 40, and what is distance covered by the car with the 50? Let's do a cool calculation here. It's a simple thing. It's nothing too big. The fact that what is common between both of them is the 5 hours. The only thing that is common between the two cars is the time. They move from the same point and they stop at the same point or reach the same point within the same time. So time is the only thing that is common. So if 5 hours, all right, so let's do the calculation here now. So let's say 5 hours multiplied by 5 multiplied by 40. So let's say 5 multiplied by 40. What do we get here? All right, let me just put it here. Let me just type it out real quick. I can go faster that way. So we're going to say 5, which is the hours, which is time. Time times the speed give you a distance. So again, from the formula, if you multiply the velocity by time, you get the distance. So multiplied by time, they're going to be 40. What you're going to get is 200. All right. So this is 200 kilometers. So the car traveling at 40 kilometers per hour will cover 200 kilometers. And again, to find the one with the 50, you just minus 200 from the 450, get the next number. But let's try to prove it in calculation first. So it'll be 5 multiplied by the velocity here, which is going to be 50. And so if you multiply by 50, what do you get here is our 250. Right? So you get 250 right there, 250 kilometers. So if you add 250 kilometers to 200 kilometers, you get 450 kilometers, right? So again, the one that moving at 50 kilometers will go faster. The one that moving at will go faster, cover more distance. 40 kilometers go a little bit slower, cover less distance, but they cover a total distance of 450. All right? All right, so it's a cool little way to look at it. That was a sweet question. Very sweet question. 48. It's a diagram shows a developing fetus, right? And here's a developing fetus. Let's kind of label the points here. So here is a placenta. So P is a placenta, the placenta. And Q is the umbilical cord. And I guess you'll know that by now because we've been talking about that. Umbilical cord. Make something mistake right there. Umbilical cord. All right. All right. And it says which two substances will pass from P into Q? So what substance pass from the placenta into the umbilical cord? What substance move from the mother into the child? Carbon dioxide and nutrients. That could not be the answer because the child, the fetus is actually releasing carbon dioxide. So A and B will be incorrect. Will be definitely incorrect because those are waste substances. And C said nutrients and oxygen. Yes, the fetus needs nutrients and oxygen, so that sounds good. Urea and oxygen, no. Urea is a waste that will come out of the fetus into the mother. Question number 49, and we're almost there. It's the table shows the temperature change when two salts are added to water, right? And it said now we have a salt of the initial temperature, we have final temperature. So right here, we know that something happened here. If you look at the values carefully, you know, this here we have an increase. So this one increased like that, and this one decreased in temperature. If you notice it, at the end it decreased. And so which statement about X and Y is true? All right, so here we're saying that dissolving of both X and Y is exothermic. So look at exothermic and endothermic, all right? So increase in temperature, what you get is an exothermic reaction because heat is produced and given off to the environment, right? So the final temperature, you're going to get a higher temperature because heat is produced and given off to the environment. And endothermic is that heat is absorbed from the environment. All right, so exothermic going to be higher, endothermic going to be lower temperature at the end. All right, and so let's see here. It's a dissolving B. It's a dissolving both both of them will be endothermic, not true. And C is saying now that dissolving of X is endothermic. and Y is exothermic. No. And so the opposite is true. So D is the answer. X is exothermic and Y is endothermic. Exothermic gives off heat, so the container will be appearing hotter. All right, number 50, last question. Sam and Dave conduct a simple investigation on the reflection of sound waves. Sam stands 60 meters from a wall and Dave stands 80 meters away from the same wall. The speed of sound in air is 340 meters per second. Here said, how long after hearing a sound from Dave's starting pistol will Sam hear the echo of the gun? And an echo is simply a reflection of the sound, right? So the sound will have to reach to, let me just kind of draw it so you get a sense of what I'm saying. So when the gun makes the sound will travel all the way to the wall, and then it will echo right back into Dave. So Dave will hear the echo there. So this one is coming from Dave. Sorry, I said Dave and Sam. I mixed up Dave and Sam just now. The sound comes from Dave onto the wall and then reflects from the wall back into Sam. And Sam will hear the echo right at this point, right? So we're looking for how long? We're looking for time. We're looking for time. So since we're looking for time, let's calculate time. All right, so a quick format we need to know is this. Quick format we need to know again is the same format I gave a little earlier. Is that speed, which is V, is equal to distance over time. And so if you want to find time as a subject of a formula, then time would equal to distance over velocity. So T is equal to the distance divided by the velocity or the speed, right? All right, so we have a speed up there. Let me just go a little bit tad up more so you're going to see the speed here. All right, so speed is 340. That's why I'm going to highlight that, 340 meters per second. All right, so let's do the calculation now. So there are two things I'm going to calculate. I'm going to calculate the time it takes to leave Dave, hit the wall, and then the time from the wall to hit Sam. So notice said that how long after hearing the sound from Dave's starting pistol will Sam hear the echo. So it must travel through both lines, okay? So let's say from Dave to wall, we're finding time, and time is distance over velocity. So distance here from Dave to the wall is 80. So we're going to say 80 divided by the speed, which is 340. All right, so it's from Dave to the wall, and that time is going to be 0.23. No, I'm wrong. Yeah, 235. Yep. All right, yes. So 80 divided by 340 is equal to 0.235. And we're going to do something else now. We need to find the next line, the time for the next line, which is from wall to Sam. All right, so from wall to Sam, and the Sam distance here is 60 from the wall. So it's going to be 60 divided by 340. And so 60 divided by 340 gives us 0.176. All right, and so the total time from Dave to Sam. So now the echo is actually, and they say the time from hearing to the echo is really traveling from Dave onto the wall back to Sam. So the total distance is going to be 0.235 plus 0.176. And so therefore get a total there of 0.411 seconds. Yeah, and so C is our correct answer. And this is the end of it, folks. That's another sweet question there again. All right, so again, folks, have a great day. Study well, do well on the examination. I talk to you soon. Take care.